Alright, this is the lesson about dilations. This is lesson 4 in Unit 8. So today we're going to look at this. This is talking about making objects larger or smaller. So let's take a look and see what we get. Okay, so a dilation is an enlargement or a reduction of a figure that is similar to the original figure. The way this works out is the scale factor is what determines how much is being dilated. Okay, so if the scale factor is larger than 1, the dilation is an enlargement. If it's a positive scale factor that's less than 1, so this means it's between 0 and 1, or a fraction, the dilation is a reduction. Okay, for negative scale factors, the dilation is an enlarged or reduced figure that is reflected through the point of dilation. Okay, so what we have here is a dilation is relative to a point of dilation. So to locate the vertex of a dilated figure relative to the point of dilation, you do this. You draw a line segment from the point of dilation through the vertex of the original figure. Measure the distance from the point of dilation to the vertex and multiply by the scale factor to produce a new distance d. Okay. Then you measure from that with the distance of d along the line that you just produced to produce the new vertex of the dilated figure. So this means that you're going to get progressively farther or closer to the point of dilation. Sometimes that will be called a focal point. Okay, this is also how they use what they use to make enlargements and reductions of pictures with cameras. Okay, example 1. Using a scale factor of 2 and a point T is the point of dilation, dilate triangle ABC to produce triangle A prime, B prime, C prime. Okay, so this is what you do. You start with your original, this is your point T, this is the point of dilation. So you draw the lines through the vertices like this, and then you measure how far this distance is, multiply it by 2, and go that distance again. Okay? Same thing here. You measure how far this distance is, multiply that by 2, and then you measure this distance to here. And that creates our larger triangle that's shown here in blue. Okay? So this is what we do. Okay, in this example, you notice that the dilated figure's vertices are labeled with primed letters. For example, read A prime as A prime. Okay? Alright. So this time they want us to use a scale factor of 3, and point T is the point of dilation. They want us to dilate quadrilateral ABCD to produce the primed quadrilateral A prime, B prime, C prime, D prime. Okay, so we follow the same procedure. We locate our original one, find the point T, draw our lines through the vertices, measure the distance, and then multiply by 3, and that gives us these 4 points right here, which we connect, and that gives us exactly the same figure, only enlarged. Okay. If triangle A prime, B prime, C prime is a dilation of triangle ABC and point T is the point of dilation, find the scale factor. Okay, so what we do is we do this. This is what you see on the standardized test all the time. So they're giving us that this point here, the point T is the point of dilation, is they're saying that's 0, 0. That's very important because if it's not 0, 0, it gets much more complicated. But here's what the thing is. Since we know that this is 6, 2, and we know this is 18.6, then we can simply compare, since this is 0, 0, we can simply compare these together. So 6 to 18, we have to multiply 6 by 3 to get 18, and if we multiply 2 by 3, we get 6 also, which gives us the other point. Okay, so that's what they're actually doing here. They're finding the distance using the distance formula. Okay, so this is going to give us 36 plus 4, square root of that, so it's the square root of 40. Okay? So what we're doing here is we're looking at this. This gives us 18 minus 0 squared, 6 minus 0 squared, gives us this, which is the square root of 360. which is exactly what we're talking about. So the scale factor is going to be D1 to D2. So if we put this over this gives us 360, the square root of 360 over square root of 40, which is this, which gives us the square root of 9, which reduces to 3. Okay? Like I said earlier, if this is 0, 0, you can just simply compare the vertices coordinates and see what the distance is. Okay? If you notice here, that corresponded with the distance 3 that we just found. Okay, this time we have quadrilateral A prime, B prime, C prime, D prime. It's a dilation of quadrilateral ABCD. They want us to locate the point of dilation T. Okay, so this time what we're going to have is you have the two figures here. So if you connect the corresponding vertices together, that where they cross, that will be where the line, that will be the point of dilation. Okay. So if you actually go back through here, you will find that this line will also intersect right there at the same point. Okay, so use a scale factor of 3 and T is the point of dilation. They want you to dilate line segment AB to produce line segment A prime, B prime. How does segment A prime, B prime compare to segment AB? Okay, so here's what we got. This is our segment, this is our point. So all we're doing is we're going out here and going here. And so what we're doing is we take this, multiply by 3 with a compass. Okay? And that gets us to this. Okay? So segment AB prime, which is this one right here, is going to be what? It's going to be the same scale factor. So it would be the scale factor of 3 and it would be parallel to the original line. Okay. All right, that concludes the lesson on dilations. If you have any questions, be sure you write them down and bring them to class tomorrow, and we'll be glad to help you with them. Thank you very much. See you tomorrow.